Hello everyone. The machine learning use case that we are going to discuss today is Twitter sentiment analysis using machine learning with Python. So in this use case, we will be training our machine learning model with loads of Twitter data. So in this case, the Twitter data is nothing but the tweets that we have. And once we train our ML model, this model can understand whether a tweet is a positive tweet or it is a negative tweet. In other words, it can understand whether a person has tweeted it with some positive intentions or negative intentions. So that will be the agenda for today's video, and let's get started. So before going into the coding part in Python, let's try to understand what is the workflow that we are going to follow for this particular project. And the first thing is data collection. So first we have to collect this tweet data, and once we collect this tweet data, we have to process this. So as we know that these tweets are nothing but textual data, right? And we cannot feed this textual data directly to our machine learning models. So machine learning models cannot understand this textual data, but they can understand numerical data. So we have to find a way in which we can efficiently convert this textual data into numerical data, and that will be done in this data pre-processing part. And once we do this data pre-processing, we will split our data into training data and test data, and this part of the code is called as train test split. This training data set is used to train our machine learning model, and the test data set that we have is used to evaluate our model. Evaluate in the sense we have to find what is the accuracy of the model and how the model is performing and so on. So that is why we are splitting our data into training data and test data. And after this step, we have to feed this training data to our machine learning model. And in this case, we will be using a logistic regression model, as this is a classification problem where we are classifying the tweets to positive tweets or negative tweets. Okay, so once we train our machine learning model, we will evaluate it using this test data. So after this, we have this trained logistic regression model. And once you have this trained model, if you feed a new tweet to this model, it can say whether that tweet is a positive tweet or a negative tweet, which is our final prediction. Okay. So this is what we are going to do in Python, from this data collection all the way to training this machine learning model and using this trained model in order to do some predictions. Okay. So let's get started with the Python part of this video. So I will be doing all this coding in Google Collaboratory. So if you haven't used Google Collaboratory before, just go to Google and search as Google Collab. So you will see this welcome to Collaboratory option. So if you click this, there will be an option called as new notebook. So once you click this new notebook, you will you will get this particular Google environment. Okay, so there will be like this empty notebook setup where you can write your codes. So I have filled in some codes already. So I'll explain you what we are doing here exactly. Okay. So the first thing that you have to do here is there will be an option called as connect, where you can connect your system. Okay. So all these are like these Python codes are executed in cloud in Google's backend server. So you don't need to install any softwares or anything. So this is like completely free for your machine learning use cases and data science use cases. So you can actually use Google Colab itself. You don't need to install any IDEs or notebooks. Okay. So this is where we'll be doing all our programming. So the next part of this video is to do this data collection. So where we are going to get this data. So in Kaggle we have this sentiment analysis data set, which is we are going to use. So go to Google and search Twitter sentiment analysis data set Kaggle, and here you will see this title called a sentiment 140 data set with 1.6 million tweets. So this is what we are going to use. So as you can see, the amount of data set that we have is like, it is a very large data set. So it contains like 1.6 million tweets, which is equal to 16 million tweets. So you can click this one, and this is actually a large data set. So the size of this data set is like 238 MB. So if you want to upload this to this Google Colab environment, it will take a very long time. So the alternate way is to load this data directly through API from this Kaggle environment to the Google Colab environment, and I'll show you how we can do that. Okay. So for this, first thing that you have to do is you have to download the kaggle.json file, which is your API token. So in this, you can see this profile icon. Okay, so this particular symbol in the top right corner, or you can also go to the Kaggle's home page. I hope that you have a Kaggle account. If not, you have to sign up for it, and also you have to verify your phone number and email address. That is like very important. If you don't do that, your API won't work. So after like verifying your phone numbers and email address, you can go to this profile icon. If you click this, you will see an option called as account. Okay, so in this account, just scroll down, and here you will find an option called as create new API token. Okay, so click this and a file will be downloaded. I have already downloaded this file, so there is a duplicate file that has been downloaded here. So it is basically a kaggle.json file which contains your account credentials. Okay, so this is the next step that you have to do. Then come back to the sentiment 140 dataset. Okay, so as you can see, this dataset contains like 1.6 million tweets, which is equal to 16 million tweets, and this is extracted through the Twitter API, and this person has kind of put this data together, and this tweets us two labels. One is 0 and the other label is 4. If the label is 0, that means a tweet is a negative tweet, and if the label is 4, that means it is a positive tweet. So that is what we are going to classify, whether the tweet has been made with some positive emotion or it is made with some negative emotion. This is what we are going to classify, and these are all the columns that we have. So we have the target, which is the 0 or 4, and then we have the tweet ID, date, flag, user, and finally the text. So the two things that are important for us are the target column and the text column. So this text column contains the actual content of the tweet that has been tweeted. So we want these two. So we have to load this data through the API that we have. So I'll show you how you can do this. So first thing is installing this Kaggle library. So in Google Colab, this Kaggle library will already be pre-installed. So if you want to work in Jupyter Notebook, you have to install this through this pip install command from Anaconda prompt or something like that. Okay, so if you're working on Google Colab, just go to this code cell and write this exclamatory mark pip install Kaggle. Okay, and in order to run this cell, you have to press Shift plus Enter. So this will run the current cell and go to the next one. So this won't be available in your new Colab environment. It will basically be empty like this. So there will be an empty cell. So here you have to fill this code. The next thing is uploading your kaggle.json file. So you know that we have downloaded a kaggle.json file, right? So we have to upload it. Here you can see an option called as files. So I'll click this. So this is the directory that we are working on, and in this directory we have to upload this kaggle.json file. So here you can see this upload to session storage option. So click this one, and this is the file that I have downloaded, kaggle.json. So you have to upload your own kaggle.json file here, and once this has been downloaded, you have to run this next cell. So this is basically not just to configure the path of the kaggle.json file. So this is just to tell where is this JSON file and how we are going to configure this. So this is the exact code. So I'll give the link of this collab file. You can just copy this code and you can run this in order to configure this path. So, and the important thing is you have to do this only after uploading your kaggle.json file. So I'll run this cell, and now we are going to import our Twitter sentiment dataset using API. Okay, so the next part of the code is API to fetch the dataset from Kaggle. Okay, so in order to get this API, so you can go to the sentiment 140 dataset, and here you will see this options symbol. So click this, and there will be an option called as copy API command. So click this one. So this will copy the API command for this particular dataset. Come back to your Google Colab environment, and just enter an exclamatory mark and paste the API command. So this exclamatory mark is very important. So if you don't include this, you will get an error. So we are going to download the sentiment 140 dataset. So this is the API that we are going to use, and just press Shift plus Enter. Okay. So this will download this dataset. As you can see, this dataset has been loaded, very quickly. So it is like an 80 MB compressed file. So if you want to upload this to Colab, it will take a very long time. So that's why we are using this, API method to do this. So this is in a zip file, right? So the next step will be to extract this zip file. The data that we need is in a CSV file. As you can see, training 16 million processed, no emotion icon. So this is the data set that we need. So we have to extract the zip file that we have. So that will be the next step. So I'll make a comment here as extracting the compressed file, the compressed data set. Okay, so from zip file. So this zip file is another library that we have in Python. So I'm going to use this library import. So there is a function called as zip file. So here Z and F should be in capital. So this is the library, and from that we are importing a specific module, and I'm going to specify the path of this dataset file, the path of this compressed file. So I'll name this as dataset. So this is just a variable, so you can name this anything. So you have to mention quotes here, and within this quotes you have to paste the path of this file. So in this, so this is the compressed file, and you can see this option symbol. So click this one and copy the path. Once I have copied this path, I'm going to paste it here. Okay, So this is the path of my file, and now I'm going to open this file and extract it. So I'll say with zip file, which is the function that we have imported. So with zip file, here you have to mention the path of the dataset, is dataset comma R. So R stands for read. So we are going to read this compressed file as zip. So again, this is a variable name. You can use anything. So I'm reading this dataset file, and I'm I'm reading it with the name zip, and I'm going to extract this. So I'm going to say zip dot extract all in parenthesis. And finally, once this is extracted, I'm going to say print the data set is extracted. Okay, so this is the code in order to do this extraction process in Python. So we are importing this zip file library, and we are specifying the path, so the path of the compressed file that we want to extract. And I'm opening this file, so I'm using the zip file function, and I'm mentioning the path of this file, which is dataset, and I'm reading this file as zip. And then I'm mentioning zip dot extract all. So this will extract all the components of this compressed file, and it will store it in my parent directory. So I'll run this one. So once this extraction has been completed, this line will be printed, which is the data set is extracted. Okay. So now the data set is successfully extracted. Now you can go to this files. As you can see, the data set is extracted. So this is the file that we want, which is this training.16 million thing. Okay. Okay, so this is in the form of CSV file. You can rename this using this. So you can go to this option. You can rename this file, or you can just keep it as such. So let me not change the name of this file. And the next part will be to importing the dependencies. So we need like several libraries and functions in order to do this sentiment analysis task. So we are going to import that required dependencies and the functions for this process. So the next part will be importing the dependencies. Okay, so importing the dependencies. First, I'm going to import my NumPy library, which is a very basic Python library, and then I'm going to import this pandas library. Okay, pandas is used to create data frame. Okay, so as you know, the data set is in a CSV file, so it is not easier to process the data and analyze the data when it is in a CSV file. So we will load it to pandas data frame. So data frames are nothing but structured tables. So we will feed this data to this structured table called as data frame, and we will do all the processing and analysis. So that's why we need this pandas. And then I'm going to import RE. So RE stands for regular expression. So this is used for us in order to do some pattern matching, search through the data, and so on. So I'm importing this RE. So again, so these libraries are already pre-installed in Google Colab. So if you are working in some IDEs like Spider or PyCharm, you have to install it separately using pip install command. And the next thing that I'm going to import is from NLTK dot corpus import stop words. Okay. Yeah. So NLTK stands for Natural Language Toolkit. So natural language processing is something that we do in textual data. Okay. So I'm importing this natural language toolkit library, which is NLTK. Corpus is the module that I'm importing. From that, I want this stop words module. So I'll explain you what this stop words means in the upcoming part of the code. So this is the next thing that we need. And later, I'm going to import from NLTK dot stem dot porter. Okay, so dot porter. I'm going to import porter stemmer. Okay, so porter stemmer. So the use of this porter stemmer is that there is a processing called a stemming that we do, which is used to reduce a word to its kind of root word. So I'll explain you this in a later part of the code where we will use this porter stemmer. And the next thing that we need is from sklearn. Again, sklearn is a very famous and widely used machine learning library. So I'm importing this from sklearn.feature extraction import tf idf vectorizer. Okay, so the purpose of this tf idf vectorizer is that, as I told you earlier, we cannot feed the textual data to our machine learning model, and we have to convert this textual data into numerical data, and that is the purpose of importing this tf idf vectorizer. So just a second. Okay, the next thing that I'm going to import is from sklearn dot model selection import train test split. So this train test split is function is used to split our original data into training data and test data, where the training data will be used for training our ML model and test data for evaluating our model. And then I'm going to import my machine learning model from sklearn dot linear model. Let's import logistic regression. So in this case, I'm going to train this tweet data or Twitter data with logistic regression. So I'm importing this logistic regression with this logistic regression from sklearn.linear model. And finally, I'm going to import my accuracy score from sklearn.metrics import accuracy score. Okay. So these are all the the 9 things that I need. So I'm importing the NumPy library, pandas, and regular expression library. And later I'm importing my stopwords, parter stemmer, TF-IDF vectorizer, and then I'm importing this train test split, which is used for splitting the data into training data and test data. Logistic regression for training my training with this data. So this is the ML model that we are going to use. And finally, we are importing this accuracy score, which will calculate the accuracy and the performance of our machine learning model. Okay. So I'll run this one. So this will import all the dependencies that we need. So cannot import name from. Okay, so there is some error. Let me just check this one. So sklearn dot idf tf idf vectorizer. Okay, so I should say from sklearn dot feature extraction dot text. So I missed this text one. So I'll run this one. Now I won't get any errors, as you can see. So these are all the dependencies that we need. So the next thing is downloading this stopwords. So I'm going to say import NLTK, and from this NLTK we have already imported this stopwords, right? So NLTK and NLTK dot download, and in this parenthesis in this quotes I have to say stopwords. So let's try to understand what does this stopwords means. So this will download all the stopwords that we have. So here I'm going to print, so printing the stopwords in English. Okay, let's say print stopwords dot words English. Okay, so this stopwatch is nothing but which we have imported here from this nltk.corpus. So then let's run this one and try to understand what these stopwords mean. So it basically contains the words like I, me, myself, we, our, ours, etc. And you can also like just scroll through it in order to understand what are all these words. So stopwords is something that doesn't add any meaning to your textual data. So it has some meaning, but it doesn't have any influential meaning. So if you remove this I from that, it is not required for us. So like these are words that is not required for our processing. So we like the machine learning model doesn't require these words. So we have to remove these words from the text that we have. Okay, so this doesn't have that much importance. Okay, so that is what I can understand this stop words. So stop words in any languages are those words that doesn't add that much importance to that context of this. Okay, so of course I, me, and my, myself, all these have some meaning, but it doesn't have that much contextual importance. So we don't need to include these words from our tweet. So what this actually does is, so we will take this stop words and we will remove those from this 1.6 million tweets. So we have several tweets data, right? So in each tweet we will remove the words like I, me, my, myself, etc. So we will keep only the important words. So that's why we need this stop words. The reason we are doing here is, as we know that the data set is very large, and we have to do everything possible in order to reduce the size of the data that we have, in order to reduce the complexity of the data that we have. And one such process is removing the stopwords, as it doesn't have that much meaning to it. So that's why we are doing this. And the next thing will be how we are going to process our data set. So this will be data processing. Okay, so here I'm going to load the data from the CSV file to a pandas data frame. Okay, so loading the data from CSV file to pandas data frame, and I'll create the data frame named as Twitter data. Okay, so Twitter data is equal to, I'm going to use the function pd.readCSV. So this read CSV function will read the CSV file and load the content to a pandas data frame. So here I have to mention the path of this file. So I'll go to this files and I'll copy. So you have to give this options, and you can copy this path of this file and put that path of the file within quotes. So in this parenthesis, you have to create opening close quotes and closing quotes. You can either use single quotes or double quotes, and just put another comma to it, and we have to mention what is the encoding here. So I'm going to say encoding is equal to ISO. So this is like a standard, a normal standard that we have. So 88591. So this is one kind of encoding that we have in this pd.read CSV. So ISO 88591. Okay. So I'll run this one. So the parameters that we are passing are the path of the CSV file and what is the encoding method that we have to use. So these are all the two things. And yeah, so now this data from CSV file has been loaded to this data frame, and we have named this data frame as Twitter underscore data. And you can check the total number of data points that are there present in this data set. So I'm going to say Twitter data. So this is for checking the number of rows and columns. Okay, so rows is nothing but the total number of tweets that you have. So I'm going to say Twitter data dot shape. So this will tell me how many rows and columns are there in my data set. So there are like 15 like 999. So this basically means like 16 lakh, because in Python indexing starts from 0. So if there are like 10 numbers are there, so the counting will start from 0, 1, 2, 3, and so on. So this basically means there are like 16 lakh tweets, because the first number starts with 0 instead of 1. So that's why we have this count. And there are totally this 6 columns. So this 6 column is nothing but my targets, as you can see. So target, IDs, date, flag, user, and text. So apart from, like, within this we just need this text and target alone, but let's go into that later. But these are like the 6 columns that we have, which is mentioned here. So there are like 16 lakh tweets and like 16 columns to it. And also you can print the first 5 rows of this data frame. So I am printing the first 5 rows of the data frame, and I'm going to say Twitter data dot yet. So this yet function will print me the first 5 rows. So as you can see, these are the first 5 rows. So we have this target, ID, or date, query, and so on. But there is like one important thing that we have to note here. So this is actually a data point, but this has been considered as a column name. So this is in bold letters, right? So what this means is, like, this is the column name, and this is my first data point. So this is my first data point, which starts with 0. So this column names are not being read by this pd.read CSV. Okay, so when we use this function, so this ID, target, date, flag, so these are all not read by this pd.read CSV, and the first value is being read as the column name. Okay, so if you see here, the value is like 0672, right? And so this is the value that we have. So we have to tell the pd.read CSV that you are not reading the column name, so you have to do that change. So let's try to do that. So I'm going to name the columns, naming the columns, and reading the data set again. So reading data set again. So I'm going to do the same task of Twitter data pd.read CSV, but I'm just going to add one more thing to it. I'm going to say column names. So column names is equal to, so I'm creating a list. So the first value in this list is target, and then the next item is ID, and then I'm adding this date, and then flag, user, and finally let me put this as text. Okay, so where I'm getting all this is from this one. So these are the column names that we have. So first is target, so that's why I made like target as the first one, and then we have this IDs, date, flag, user, and text. So I have named all these columns, and now I have to read this dataset file again. So I'll copy this part of code, this line alone. We copy this and put it here. Okay, now before this encoding, I'm going to use another parameter, which is names. So names is equal to column names So this column name, so you have to put another comma here. So this column names is nothing but the column names that we have created here. So I'm using this pd.read csv. I'm reading this csv file, and this is the name of the columns I have to create for my data frame, and this is the normal encoding that we are going to use. I'll run the cell again. Okay, so now I'll copy this one. So now it will show this as 16 lakh tweets are there. Okay, so 16 lakh tweets are there because previously what happened is, like, the first tweet has been read as a column name. So this is actually the first tweet, but it was like read wrongly. So in this case we can correctly read this like there are like 16 16 lakh tweets are there, or 1.6 million tweets are there, and we have like 6 columns. So I'll run this twitter.it again. So now this will give me a different data frame which has column names. Okay, so as you can see, so first column that we have is the target column, which contains the value as either 0 or 4. So as you can see, so 0 means it is a negative tweet and 4 means it is a positive tweet. So this is the labels that we have. So we call this labels as target. And the second column, we have this ID. So ID for each of the tweet, and date on which the tweet has been made, flag whether there is a query or not, and what is their username, and finally the text. So this text is nothing but the actual content of the tweet. Okay, so we have loaded this data frame. So previously it looked like this without the column name, and that's why we have included this column name, and we have done this. Okay, so this is how you can load your Twitter data from CSV file to this data frame. And the next thing that I'll do is I'll check whether there are any missing values. The other important thing that we have to do is, like, often when we deal with a data set in machine learning, a lot of values will be missing. So if values are missing, we have to replace those values with some other values, or we have to drop those values. So in this case, let's see whether any values are missing. So this part will be counting the number of missing values. Missing values or text, in this case missing values in the data set. Okay, so I'll mention Twitter data, which is the data frame name, the data frame which we have created. So Twitter data dot is null. So here I have to mention the parenthesis dot sum. So is null means, so null means missing values. Okay, so I'm checking whether there are any null values using this is null command. So this is null command is present in pandas, and I'm calculating the sum. So this will tell me how many missing values are there in each of the 6 columns. So we have 6 columns, right? So this function, so this code snippet will tell me how many missing values are there in each column. So I'll run this one. As you can see, all the values are 0, which means no values are missing in this case, and that is a fortunate thing because we don't need to process this data set anymore. So all the values are present, and then we can move on to the other processing part. So now let's try to understand what is the distribution of this target variable. So here it is mentioned as 0 means negative and 4 means positive. So here they have mentioned as, like, there are like 3 labels. 0 as negative, if the value is 2 it means neutral, 4 means positive. Let's see how many labels are there. So this will be checking the distribution of target column. So this is basically to check how many positive tweets are there and how many negative tweets are there in our data set. So totally there are like 1.6 million. So how many positive and negative tweets are distributed in this data set? So for this I have to mention the data frame name, which is Twitter data, and within square bracket I have to mention the column for which I am checking. So I am checking this for target column, right? So within this parenthesis I have to mention the column name, which is target, and dot value counts. So this will count the number of values of 0 and 4. So value counts parenthesis. Let's run this one. So as you can see, the number here is 8 lakhs. So 8 lakhs tweets are there for the label 0, and 8 lakh tweets are there for the label 4. So when you add this, the total value is like 1.6 million. So that is like a very equal distribution of the tweets that we have. And if you go here, so we have like the annotations as 0 as negative and 4 as positive, but in this case they have given us neutral. But this is an error because the data set contains like only two labels. One is 0 and 4, where if the label is 0, that means the tweet is a negative tweet, and if the label is 4, then it means the tweet is a positive tweet. So that is the inference that we can get, and the data has been equally distributed. So the reason for performing this operation is that If the distribution is not even, we have to do things like upsampling and downsampling to make this distribution as even. So if you work with an data set that doesn't have even distribution, in that case your machine learning model won't work properly. So this is a very important step that we have to check. In this case there is an equal distribution, so we don't have to do anything here. So these are like very important, checking whether there are any missing values and whether the distribution is even or not. So we will perform these things in any machine learning use case that we do. Okay. So now what I'm going to do here is, here the label is 0 and the label the other label is 4. So I don't like this label. So it is not a good way in order to have the labels as 0 and 4. So what I'm going to do here is, I'm going to convert this 4 to 1. Okay, so that I will have the labels as 0 and 1, where 0 means a negative tweet and 1 means a positive tweet. Okay, so this part will be, will make a text here as convert the label or the target, convert the target 4 to 1. Okay, so 4 to 1. Okay, so this is the conversion that we are going to make. So I'll mention Twitter data. So all these things comes under data pre-processing. So that's why I told you, like, we cannot feed the raw data to our ML model. So we have to perform various processing things. So Twitter data dot replace. So within this parenthesis, we have to mention what we are going to replace. So open a curly bracket and I'm going to say target of 4 colon 1 comma in place equal to true. Okay, so let's try to understand what we are doing there. So basically, I'm taking this data frame and I'm going to replace certain values. So I'm going to replace the values in this target column. So how I'm going to replace this? I'm going to replace all fours to 1. So this is the conversion that I'm making, and I'm mentioning this in place is equal to true. So in place is equal to true means, so this change has to be stored in my original data frame. So if you don't do this in place is equal to true, this change of replacing 4 is to 1 won't be stored in your original data frame, which is your Twitter data. So including this in place is equal to true is very important. So we are just converting all the values of 4 to 1 within this target column. So I'll run this one. Okay, so invalid syntax, in place is equal to true. Okay, so we have another curly brackets. Okay, so we have the opening curly bracket and ending curly bracket here. So this is actually in the form of a dictionary. So this is an Python dictionary data type. So I have wrongly included another curly bracket here. So that's why we are getting this error. So I'll run this cell again. Okay, in place is equal to true. So I'm getting this error again. Let me check. So Twitter data dot replace target is to 4 is to 1. Okay. Okay. So the thing is, here we have one curly bracket and we have another curly bracket here. So we have to close the curly bracket here. So this is the error that we add. So let me run this cell again and check whether this is working properly. Yeah. So this cell is executed. So previously, as we can see here, the two values that we add in our target column are 0 and 4. Now I'll just copy this one and I'll paste it here and I'll run this cell again. So now all these four values has been converted to 1. So this is the basic conversion that we are doing. So we have like 8 lakhs tweets or 800,000 tweet which has no negative emotion attached to it, and 8 lakh tweet which has positive emotion attached to it. So we have just replaced this 0 as such. So we are not doing any change in the label 0. We are just changing this 4 into 1. So which means, like, if a target value is 1, that means it is a positive tweet. So I'll make another text here as 0 means negative tweet. Okay, and let's say if it is 1, that means it is a positive tweet. Okay, so this is what the machine learning model is going to understand, whether the tweet is a negative tweet or it is a positive tweet. So we'll be training it with the 1.6 million tweets that we have, and then we will test it for evaluation. And the next thing that we are going to do is called as stemming. Okay, so I'll make a text here as stemming, and I'll just make this in bold. So for this purpose only, we have imported the function called as spotter stemmer. So I'll explain you what is meant by this stemming. So stemming is a process that we do in order to reduce a word to its root word. Okay, so I'll just put that definition here as well. So stemming is the process of reducing a word to its keyword, or let me name this as root word. So root words are nothing but, let's say there is an example. So I'll just give you an example for this. So let's say that there are like words like actor and let's say actress and acting. So these are like words that are similar meaning, right? So we kind of take all these words and change those all this to those keyword, or what we call as a root word called as act. So I shouldn't use the term keyword, so we have to say root word. So the root word for actor, actress and acting, all these things are act. So the reason we are doing this is, as we know that the data set is very huge and we have to do some processing in order to reduce the dimensions and the complexity of the data. So we are taking all the words and then we are reducing these words to its root word, so that it is easier for our machine learning model in order to go through the data and understand whether the tweet is a positive tweet or a negative tweet. So this is a very important part in this sentiment analysis, where we are taking each word of this tweet. So there are like 1.6 million tweets, right? So we are taking each word from each tweet and then we are kind of reducing it to its root word. So that's what we are doing here. And for this, I'm going to use the Porter stemmer function that we have created. So Porter stemmer. So I'll create a variable as pot stem. So this is where we are going to load the instance of this Porter stemmer function that we have imported. So Porter stemmer in parentheses. So this will load the instance of this Porter stemmer module, or the function which I imported to this variable called as pot stem. So I'll run this one, and now I'm going to create a function. So we know that in Python we use this term def, which stands for define, and this is used to create some function. Okay, so I'm creating this function called as stemming, and I'm going to say content. Right. Okay. So content, and so when I call the stemming function, I want this process to be completed, which is like reducing the word to its key to its root word. So I'll create a variable called as stemmed content. Stemmed content is equal to re.sub. So this re.sub is nothing but, so we have already imported our regular expression library. So the short form for regular expression is re. So from this regular expression library, I'm importing this sub, the sub module. I'll explain you what this particular sub function does. Let me just complete this one. So I have to mention quotes. I have to mention a list with opening square bracket and closing square brackets. I have to say upper arrowhead A to Z, capital A to capital Z. Later, I have to say this quotes, there has to be a space, and later has to be this content. So I'll explain you what we are doing here. I'll just complete this particular function. I'm going to call the stemmed content again. Stemmed content is equal to, I'll copy this one, dot lower. Okay, so lower in the sense we are converting all the uppercase letters to lowercase letters, because we don't need this we don't need a letter to be uppercase in order to do this processing. If it is in lowercase, it is sufficient for us. So that is why we are converting that. And I'm going to say stemmed content dot split. So once we do this stemming operation, we have to split all those words into so we will split all these words and we will store it in a list. So I'll explain you in detail about this later. And stemmed content is equal to, so this is where we are going to use the pot stem function that we have, PORT stem, pot stem dot stem word for word in stemmed content, if not word in stop words. So this may look a bit complex, but this is actually very simple. I'll explain you in a moment. Stemmed content dot words English. Okay, so there is like one more step, which is stemmed content is equal to space dot join stemmed content, and finally we can return this Stemmed content. Okay. Okay, so when I call this stemming function, I want all these processing to take place. Okay, so what we are doing here is, so content is nothing but, so in this content within this function, we are going to pass this text column. So text column contain all the tweets, right? So we are going to pass these tweets because we don't need any other, column. So we just need this target column and this text column, which is basically the tweet. So we don't need anything else. And I'm going to process all these text because like this target is already in the form of numerical value, right? Either 0 or 1. So the machine learning model can understand it, but it cannot understand this text. So before converting this textual data into numerical data, we have to do some more processing, and that processing is called as stemming, which is to reduce a word to its keyword. So before doing that, we are doing some, like few other steps here. So I'm taking like the content. So here the content is nothing but each tweet that we have in a data frame. So all this 1.6 million tweets will be processed individually. So first thing we are doing here is re.sub of A to Z and capital A to Z and content. So we are taking this content and I'm going to remove all the things that is not alphabet. So when I say A to Z, so lowercase a to lowercase z, that means like all the alphabets, like lowercase a to lowercase z, all the alphabets, and this capital A to capital Z means all the uppercase letters. So and this means this upper arrowhead means I'm going to remove those words. So upper arrowhead, you can just press shift plus 6 in order to get this arrowhead, as you might know already. So I'm going to take each of these tweets and I'm going to remove if it is not this, if it doesn't belong to this list. So this is nothing but small a to small z, and this is like capital A or uppercase A to uppercase Z. If a word or a letter doesn't belong to this one, I'm going to remove it. Okay, so if you see this one, we have this at symbol, right? So this will be removed, and we have this number 2 is there, and some punctuations are there. So we are going to remove all the things that is not a letter. So that is what we are mentioning here. So this is the list that we are considering. So we are just matching some patterns. So the pattern that we are matching here are letters, so alphabets, English alphabets. So when I say this upper arrow, that means I wanted to remove everything that is not A to Z or this capital A to capital Z. So that's what I'm doing here. So once you pass this content, so each tweet will be processed each time this function runs, and we kind of like you know remove all the things except for letters. So if it is at symbol, or if it is like any other special characters, or it is two, or if it is a punctuation, we kind of remove all those things because we don't need all these things in order to understand whether a tweet is a positive tweet or a negative tweet. So that's the reason. So that is the first step. After that, we are converting all the letter to lowercase letters because we don't want the uppercase letter. So if we it doesn't add any meaning to the context of the tweet. So a letter being like a capital letter, or in other words, an uppercase letter or a lowercase letter, doesn't influence the context of that particular tweet. So we are going to convert all the letters to lowercase letters, and once we do that, we are going to split all the words from this tweet, and we are going to load that into a list. So that's what we are doing here. So I'm going to split all the words in a tweet, and I'm going to put that in a list. So if you consider this one, so the first word will be in the list, and the second word will be in the list, and so on. So that's what we are doing here in this dot split function. And after that, we are using this pot stem, and as I've told you, the purpose of this pot stem is to reduce a word to its root word so that we can save some space. We can make this processing easier. So here what I'm doing here is pot stem dot stem of word for word in stemmed content. So stemmed content is nothing but, so this is where we are storing all this processed content. So first we are like removing all the special characters, numbers, and punctuations, and all those content that we need has been stored in the stemmed content. So this stemmed content will contain only letters and words. So it doesn't contain any numbers or special characters. After that, we are converting into lowercase letters, and that will again be stored in the stemmed content. And then we are splitting it to a list. So once we do that, we are taking each word in the stemmed content, and we are checking if that word is present in the stop word. So it should be stop words. As we know that stop words are nothing but the words that we don't need, that doesn't add that much meaning to the context of that tweet. So these are the stop words. So when I say hot stem dot stem of word, so this stem function will reduce my word to its keyword. So what words I'm going to do the stemming operation is for word in stem content, if not word in stop words dot English. So if a word doesn't belong to the stem words, and in that case, I'm going to process the stemmed content, because it's like there is no meaning in performing this stemming operation and for the stop words, because we don't need those stop words. So that is the reason. So if a particular word is not in the stop words, stop words are nothing but this I, me, my, myself. So in that case, I will perform the stemming operation. Okay, so if the word is present in the stop words, in that case I won't do the stemming. I will just basically ignore those words, and I will just join all those things. So this is like again joining all the tweets together. So let's say that first tweet is there, and there are like 10 words in that particular tweet. After doing all this processing, we will combine this tweet together. So in this step, we are splitting each word, and this stemming operation is done. We will join all the words in a particular tweet. So let's say that there are like as I've told you, 10 words in a tweet. So in that tweet, when this function run, we will remove all the punctuations, special characters in that first tweet, and then later we will kind of replace all the uppercase letters to lowercase letter. Later we will split all the words into a list. So that tweet which contain 10 words will now be converted to a list, and that list will contain 10 individual words from that list. After that, we will check whether that words present in the tweet is a stop word. If it is not a stop word, we will perform the stemming operation, and we will join this words back, so that we know that it is one particular tweet. So this is the process that we do. First, we will check for special characters, numbers, or punctuation. Later, we will convert it to lowercase letter. Then we will split each word individually, and then we will perform this stemming operation individually to these words. So once this has been done, each tweet will be joined. So I'm not telling that all 1.6 million tweets will be joined. So I'm not telling that. So when you are performing this, individual words in this first tweet will be splitted. So after all this processing, we will join this tweet. And second time, we will do all this processing in the second tweet. And once all this processing has been done, we will join all the words in the second tweet. So that's what happens here. And this process is what we call as stemming. Okay. So I hope you understand this one. So this is the most important part of this code. So I'll run this function. Now we have to apply this function to the text data that we have. So this step is just like building the template for our stemming function. Now we have to apply this function to the data that we have. So I'm going to say Twitter data, and within this I'm going to create another column. So if you want to create another column, you have to mention the data frame name. In this case, it is Twitter data, and within the square bracket in the parenthesis, you have to name the column. So I'm going to name this as stemmed content. Stemmed content. So this is the new column that I'm going to create. So the data to this new column is nothing but the stemmed content of the tweet. So Twitter data of text. So text is nothing but the tweets that we have. I'm going to say dot apply stemming. Okay. Okay, so this is the step. So we are calling this Twitter data stemmed content. So I'm creating a new column, and for this new column, the data is stemmed content. So I'm taking this Twitter data dot text. So this is nothing but this column alone, this text column alone, which represent my tweet. So I'm taking this values alone, because we don't need any other details. Okay, so I'm taking this text, and here I'm applying, right? So here it should be like dot. I'm applying stemming. Stemming is nothing but the function that we have created here, right? So that's what we are doing here. So when you run this one, all these operations that we have mentioned here will be performed on all the tweets that is present in a data frame. Okay. So we have successfully run this function, and now we have to run this stemming operation. So when you run this, this operation will be performed on each individual tweets, right? And here's the catch. This stemming operation will take a very huge time in order to complete, because the reason is, as we have like 1.6 million tweets, which is equal to like 16 lakh tweets, right? So it will take a very it takes a lot of time. And I checked that it took about like 15 minutes in order to complete this tweet. Not 15, it took like 50 minutes for this. So I mentioned this here as 15 minutes to complete this execution. Okay, so you have to wait for this. So you have to wait like 50 minutes in order to complete this step of stemming. So I've created another file where I have already started this stemming operation, and this process has been completed. So all the other codes are basically the same thing, from pip install to Kaggle all the way up to this stemming. All the things are same, but it has been completed. Here you can see So these cells took like 0 seconds. So these cells like executed quickly. Whereas if you see this one, it is represented as 50M, which means like it took 50 minutes in order to complete this step. Okay, so it will run for a long time. So I have created another file so we can quickly go through this. So if you are working on this on yourself, so you have to wait for 50 minutes. So there is like no other options. Now we can continue with our part. Okay, so let that code runs. We are just continuing this code in this collab file. So there is like no change between this collab file and this collab file. So Twitter data dot date. So I'm going to print the first 5 rows of this data frame. So here you can see we have another column called as stemmed content, whereas previously the stemmed content was not there, right? Because we are performing the stemming operation and storing the content to the stemmed content. So this is the final thing that we need. So we will be using the stemmed content and we will be using this target. So we will basically like ignore all the other columns because we don't need this. So we have, this column has been made from this text column, right? So this is the raw data and this is the process data. So we will take the stemmed content and target for our training our ML model. So this process is called as stemming, where we are doing all this processing of removing the stop words and removing the special characters, numbers, and punctuations, and later converting the uppercase letters to lowercase letter, then and splitting each word in a tweet to a list, and then like performing the stemming operation and joining the words back together. So this is what we have done, and we have built this stemmed content column, right? And I can also print this column alone. So I can say print stemmed content. Okay, so I have to say print uh, Twitter data. I have to mention the data frame, which is Twitter data stemmed content. So this is the tweet data that I'm going to use. As you can see, there are like 16 million. As I've told you before, the indexing starts from 0 in Python. So 0, 1, 2, 3. So that's why we have like 1 less than 16, like 16 lakhs. So this is actually like 16 lakhs tweets are there. As the numbering starts from 0, this is the number we have. So you can see the length here, which is like 1.6 million or 16 lakh. Okay. So, but the indexing starts from 0 and the one less than this 16 lakhs. So that's what we have here. So this is the data that I want in order to train my ML model, and I'll also print this target. Okay, instead of the stemmed content, I'll print target, which contains the label either 0 or 1. Okay, so 0 means negative tweet and 1 means positive tweet. So these two things are the ones that we need. So we will pass this tweets and we will pass whether that tweet is a positive tweet or a negative tweet. Now the model will try to understand what is the relationship between this positive tweets and one, and negative tweets and 0. So it kind of understand if a particular word is there, it means like that it is a negative tweet. If a positive word is there, it will know that the intention is positive. So we want like these two things alone. We don't need this a tweet of the ID, date, or flag in order to know whether it is a positive tweet or a negative tweet. So that's the reason. Say, for example, you don't need a person's username in order to understand whether they tweeted something positive or negative, or you don't need the date or time in order to understand whether a tweet is a positive intention tweet or it is a tweet with negative emotion. So that's the reason we don't need any other things except for this tweet and the target. Okay. So this part will be separating uh, the data and label. Okay, so in this case, the data is the tweet and label is the target column, either 0 or 1. So I'm going to create two variables. One is X and the another one is Y. So in X, I'm going to store all my tweets, and in Y, I'm going to store all my target. I'm going to say Twitter data of stemmed content. Okay, so as you can see, this cell is this keeps on running. So it will take, as I've told you, 50 minutes to complete. We can continue with this one dot values. And for this, I'm going to say Twitter data target dot values. Okay, now I'll print this X and Y separately. So this is how you can split your data and labels. So this is my stemmed content. So this may seem low, but this actually contains like 1.6 million tweets. So like we are just seeing the like shortened way. So like the first few tweets and the last few tweets. So that's why this is like looking like this. So this is the stemmed content that we have, and then you can also print this Y. Okay, so like again we are seeing the first three target and the last three targets. Okay, so again there are like totally 1.6 million data points are there, and the next thing that I have to do is split this data into training data and test data. As I've told you, once we have a data set, we have to split this data set, and training data is used to train my model, and test data is used to evaluate my model, right? So this part will be, I'll put a text here as splitting the data to training data and test data. Okay. So for this, we have to create four arrays: x train, x test, y train, and y test. So these are the four arrays that we are creating, and I'm going to use the train test split function. Train test split, and within this we have to say x comma y, and test size is equal to 0.2, and stratify is equal to y, and finally random state. I'll explain you what all these attributes mean. Just wait for a moment. So random state is equal to 2. So let's try to understand this. I'm using this train test split function. So we have already imported this train test split function from here, as you can see. So this train split function is used to split the data to training data and test data, right? And I'm creating like four arrays. The first array is x train, x test, y train, and y test. So x train will contain all my training data at weights. Okay, so this x train is splitted from this x. It will contain all the training data at weights, and the corresponding label, this corresponding target, are stored in this y train. And the x test contain my test data tweets, and y test contain whether it is a positive tweet or a negative tweet for all this x test. Okay, so this x train and y train are linked. This x test and y test are linked. Okay, so this is my tweet for training data, and this is the target, the label for my training data. This is the test data tweets, and this is the label for test data. Okay, and then we are doing this by train test split function, and we are splitting with this x and y, right? So x is my tweet and y is my label, so we have to mention x comma y. And what is your test size? Test size means like how many data points you need for test data points. So 0.2 means 20 percentage of my data will go to my test data, and 80 percentage of data will go to my training data, right? So out of 1.6 million, 80 percentage of this will be my training data, and 20 percentage of 1.6 million will go to my x test data. So this is the general proportion that we use. You can consider either 20 percentage of the data as test data, or 10 percentage of the data as your test data. If you mention 0.1, that means like you want 10 percentage of data as your test data. Okay, so I'll just put this as 0.2 alone, and stratify is equal to y. So what the stratify means is I want almost an equal distribution of 0 and 1. So this means like in the training data, if the proportion of positive tweet and the negative tweet is like 50 percentage, it would be the same in test data as well. So if we don't do that, there is a chance that all the negative tweet may go to this test data instead of this training data. So we need the stratify is equal to y in order to tell this train test bed that I want equal proportion of the two classes, which are 0 and 1, both in my training data as well as test data. So that is the purpose. And finally we have this random state. So if you run this train test bed without this random states, you can also run this without this random state. If you do that, each time you split your data will be splitted, differently. So it will be a random split. If you mention this random state is equal to 2, it will the splitting will be replicated. Let's say for example, I'm using this random state is equal to 2. Let's say that you are practicing this code, and instead of 2, you are using a value as 5. So your data will be splitted differently, and my data will be splitted separately. So if I use this random state is equal to 2, and let's say you are also using this random state is equal to 2, in that case, your data and my data will be splitted in the same way. So that is the reason for this using this random state. Okay, and you can also print the x train. So let's print this x dot shape, x train dot shape, and x test dot shape. Okay, so as we can see, there are like 1.6 million data. So this is my original data set. So 80 percentage of this 1.6 million is this. which is I think 1.2 million, and the remaining data goes to my, so this is like 20 percentage of 1.6 million go to my X test. So this is how this train test split works. Okay, so you can also try printing this X train and X test. So this is my X train, then print my X test. Okay, so this is my training data which contain like these many data points, and this is my test data which contain these many data points. And now we have another important thing that we have to do. So before training our ML model, as I've told you, ML model doesn't understand text, right? So we have to convert this text into numerical values. So this is where we will use a process called as feature extraction, where we are going to extract the feature from this text, or we are going to use a method called as vectorizer. Okay, so this part of the code will be converting the textual data to numerical data. Okay, and I'm going to create a variable called as vectorizer, which is equal to tfidf vectorizer. Okay, you have to mention parentheses. If you remember, we have imported this tfidf vectorizer while importing the dependencies. So this one. So from sklearn.featureExtraction.text, I'm importing my tfidf vectorizer. So this was, so this one will convert my textual value into numerical values, so that my ML model can understand what is present in this particular data set. So I'm going to say xtrain is equal to vectorizer dot fit transform of xtrain, and x test is equal to vectorizer dot transform x test. Okay, so let's try to understand what we are doing here. So this function, as I've told you, will convert all the words into some numerical values, and it is important that we have to understand how this works. So this vectorizer function will consider like each word, and it will give some importance to each word. So like there is some, like let's say that there is this word called as fine, right? So it will check how many times this fine has been repeated in my overall tweet. So in my overall data, how many times fine has been repeated. So so that like this fine will get some importance. And there is like another word called as time and then chat. So based on that repetition, it kind of get some importance value. So we are like encoding all the textual data to some numerical values, which kind of tells us importance, right? So once we have this specific value, so each word will have one specific value. So once we do that, our machine learning model will try to correspond that numerical value, which is the importance value, to either 0 or 1. So let's say that there is a word called as fine, or let's say that there is a word called as happy. So those are like positive words, right? So these words will get an importance score based on how many times these words has been repeated. So let's say that this happy word has been repeated for positive tweets, and let's say that no negative tweets as the text happy. So in that case, the model can understand that, okay, if a word happy is present, then in that case it is a positive tweet. If a word like sad, or words like that present, we can say that it is a negative tweet. I'm just giving you one example, but the ML model will consider a lot of different words in a particular tweet. So we will take all the words in a tweet. So all the words has been converted to some importance value, and after that, the ML model will try to understand what is their importance, and it will check whether it is a that particular word corresponds to positive tweet or a negative tweet. So this is the process of this TF-IDF vectorizer, which is just to assign some importance to each individual word. Okay, so I'm like loading an instance of this TF-IDF vectorizer function to this vectorizer, and I'm transforming my training data and test data here. Okay, so I have this xtrain, and I'm using this vectorizer. So this vectorizer is nothing but this variable vectorizer. I'm fitting and transforming. So I'm fitting my vectorizer to my training data and transforming this. So the result of this line of code, this fifth line of code, is that all the training data will be taken, and based on this data, the vectorizer will give score to all the individual words. Okay, so there will be a particular transformation, and based on this transformation, we have to transform the test data as well, because like you cannot have words in training data, numbers in test data. So the data type should be the same. So we are transforming all the training data, and based on this transform, we have to do this transformation in the test data as well. So as you can see, I'm fitting and transforming the extrain here. So there are like two processes happening. So one is like fitting the vectorizer. So fitting means it tries to understand what is the nature of the data that is present there, and transforming is converting the data to this textual data to numerical values. So in this X test, I'm using this transform alone. So you shouldn't use like this fit underscore transform. So it is a wrong procedure. You have to fit and transform only this training data, and the test data has to be transformed based on how this training data has been transformed. So this is very important. So you have to use fit underscore transform this for this training data alone, and only transform for this test data, right? So I'll run this one. So this will do all those processing. So let's wait for this to complete, and now I'll print my xtrain and xtest. My xtrain and print xtest. So this may also take some time, but it won't take that much time. Okay. So previously we have printed this xtrain and xtest, right? So previously it is in the terms of words, and when I print this after this vectorizer, it will convert all those values to numerical values. Okay, so this is completed. So this took like 29 seconds. Okay, now I'll print my xtrain and xtest. So this is how my xtrain is kind of looking like, and xtest is looking like. Previously it looked like this, which as word. So this is how vectorizer will convert this textual value into numerical values. So zero means these are the like words in the first tweet, so those are mentioned like zero. These are like the words in the second tweet, and so on. So this is how like this works. Okay, so all the words in all the tweets get some importance value based on its repetition on that particular data set. Okay, so this is how we can do this conversion, and all the processing are done. So we just have only one more thing, which is to train our machine learning model. Okay, so all the data pre-processing and train test bit has been completed. So this part is training the logistic regression model. So, or let me put this as training the machine learning model, and the machine learning model that we are going to train in this case is logistic regression. Okay, so we have already imported this logistic regression from sklearn.linear model, as you can see. Yeah, so sklearn.linear models. I'm going to train this logistic regression. Again, logistic regression is a classification model. You can use it to classify the data points into different classes. In this case, the two classes that we have are positive tweet or negative tweet, right? So I'm going to create a variable called as model. So model is equal to logistic regression. Okay, I'm going to say max iter. So I'm specifying the maximum iteration. So maximum number of times the model has to go through the data. Okay, so like it is not like only one step. So the model will go through the data again and again till it reaches a good accuracy. And this is the maximum number of times. Maximum iter means maximum iterations, which means maximum number of times the model can go through the data. Okay, so I'm loading this logistic regression to this instance to this model, and I'm going to say model.fit. So model.fit xtrain and ytrain. Okay, so ytrain is nothing but my training data tweets, and ytrain is the target for this training data tweets. Okay, so which we have seen previously itself. So xtrain is my training data tweets. From this, so this x will be split into two groups. One is training data, which is 80% of the data, and 20% test data. So this training data, the corresponding labels are stored in this ytrain. So we have to feed this xtrain and ytrain to our machine learning model. So that's why I'm mentioning model.fit. So this is where the model will learn from the data. Okay, so xtrain comma ytrain. So I'll run this one. So this will also take some amount of time to train using this data, because like there are like almost 1.2 million data are there, which is like 80% of the data. So in this, what happens in this is, so the model will try to understand what are all the words that contributes to positive tweets and what are all the words that contributes to negative tweets. So I'm just telling this simply, but there are like a lot of complex procedures that is happening there. So it will try to kind of map the positive tweets to the label 1, and map the negative tweets to the label 0. So it will kind of try to find what is the relationship between this x and y. So that is what is happening here. So once this training process is completed, we can evaluate our model in order to determine what is its accuracy. Okay, so let it run. Let's complete the other part of the code, this model evaluation. Okay, So for this model evaluation, we are going to use something called as accuracy score. This accuracy score, if you remember, we have imported this accuracy score function previously from this sklearn.metric. So it will calculate like how many correct predictions are made by the model. So let me put this as accuracy score on the training data. And I'm going to create a variable called as xtrain prediction. Okay, so this xtrain prediction is equal to model.predict xtrain, and this is my training data accuracy. Training data accuracy is equal to accuracy score. So this is the function that we have imported, accuracy score. So within this we have to give the correct labels and the labels predicted by our model. So I'm going to say y train and xtrain prediction. Okay, so what we are doing here is, so once this model has completed learning from this data, we will make predictions with this xtrain itself. So in this case, as you can see, previously we have trained our model with the tweets as well as the labels. In this case, we are giving only the tweets. Now the model has to find what is the target, whether whether the tweet is a positive tweet or a negative tweet. In other words, it will predict the value as either 1 or 0. So these are the values predicted by our model, and those are stored in this xtrain prediction. Now we have to compare this xtrain prediction with our true labels. The true labels are nothing but my y train that we have splitted here, that we have splitted using this train test split function here. Okay, so we are just comparing the true values and the values predicted by our model. So in this case, the true values, or you can consider this as the ground truth, with the values predicted by our model. So these are the predicted values. So when you run this one, you will get this accuracy score. And once this is done, I'll print this accuracy score as well. So let me put this as print accuracy score on the training data. Okay, so accuracy on the training data is equal to training data accuracy. Okay, so the model has completed training. So this took about 3 minutes. Okay, so I'll run this one. So this will predict the training data labels, and this will tell me the accuracy score by comparing the true values and the predicted values. Okay, and now let's print this training data accuracy and let's see this. So the accuracy is 0.8102. So this means like the accuracy score of the model is 81 percentage. Okay, so the value won't be represented in percentage, but will be represented between the value 0 to 1. So if the value is 0.90, that means the model is 90 percentage accurate. In this case, the model is 81 percentage accurate. So what does 81 percentage accuracy means? If let's say that we have trained our model, and if you use this model in order to predict new tweet, whether it is a positive tweet or a negative tweet, in that case, out of 100 tweets, your model can make correct predictions for 81 tweets. So remaining 19 tweets, it can predict wrongly. So that is what is meant by this accuracy score. Okay. So if the accuracy score is 95, that means like out of 100 tweets, it can make correct predictions for 95 tweets. So this is what accuracy score means. Okay. So this is like, instead of being in the range of hundreds, it like 80 percentage or 90 percentage, we are getting the values between 0 to 1. So 81 means 0.81 means like 81 percentage, and so on. Okay, so this is the accuracy score on training data, but this is not sufficient. We have to calculate the accuracy score on the test data. The reason is the model has been trained on this xtrain itself, so it kind of knows how the training data looks like, but it doesn't see the test data before. So we haven't shown the test data to the model, right? So we have to check the accuracy score on test data, which is very important. So I'll copy this one. I'll change this accuracy score on the training data to test data. So here I'm going to change this X train to X test predictions. So here I'm giving only the X test, and this will be my test data accuracy. So I'm converting all this training to test. So this Y train has to be replaced by Y test. So this X train should be replaced with X test. Okay. And then we will print this test data accuracy as well. Let's see what is the accuracy on text data. Okay. Let's run this once. X test prediction model.predict. So as you can see, we have performed this X test split, this train test split, and X test is my test data, and Y test is the labels for it. In this case, if you see here, we are using the model to predict the labels for the test data, and after that we are comparing this test data prediction with the true test labels, which is Y test. Okay, so I'll run this one, and let's print this accuracy score, and the test data accuracy is 0.778, which means the test data accuracy is 77.8 percentage. As we can see, the training data accuracy and the test data accuracy is very close to each other. So in this case, we can say that the model has performed well. So there are cases which we call as overfitting, when the training data accuracy will be more, whereas the test data accuracy will be very less. Say for example, if the training data accuracy is 81 percentage, the test data accuracy will be like 40 percentage or 50 percentage. So that is what we call as overfitting. So overfitting means the model hasn't learned properly. Okay, so this is why it is important to check the accuracy for test data as well. So just convert this to test. Okay, so the reason we are calculating this test data accuracy as well is, so let's consider this example. Let's say that you are studying for your maths exam and you are practicing, let's say, 100 questions or 100 mathematical problems, and you're just writing a test by yourself with this 100 problems. So you will get a score. As you have already seen these questions, you will get a good score. And let's say that there is an examination, and in the examination they not only ask the question that you prepared, but they will ask different questions based on that particular concepts. If you are prepared well, you should answer those questions correctly as well, right? So it is similar to it. So training data is like the data on which the model has studied. So it is like the questions that you have practiced, and test data is like the questions that you don't know. So those are like questions that are set by the questionnaire, but these are like the same concept. It's similar to the concept that you have prepared. So this is why the accuracy score on the test data is important. The reason being, the model has already seen the training data. So that is why we kind of use this test data accuracy as the final one. So we don't consider this training data accuracy, but we have to calculate both of these things in order to see whether the model has overfitted. Where overfitting has happened, that means like the training data accuracy will be very high and the test data accuracy will be very low. So let me put this as model accuracy. So this is like model's test data accuracy is equal to 77.8 percentage. So 77, like 77, which is almost equal to 80 percentage, is actually a good accuracy score. If the accuracy is greater than 75 percentage, we say that it is a good model. And there are also like techniques like grid search CV and randomized search CV, what we call as hyperparameter tuning. So if we get a low accuracy, we kind of perform all those things in order to increase accuracy. But let's not go into that in today's video. So it's kind of like deviating from this concept of Twitter sentiment analysis. So we will discuss about this hyperparameter tuning in a later video. Okay, so I'll just show you how you can save this model. So we have done all these processings, right? So from like importing the data set, processing it, and training the model and so on, which took a very long time. Now I'll show you how you can save this trained model, which is my model. So model.fit. So with this model has learned, right? So I'll show you how you can save this model and how you can use this saved model afterwards without doing any of this training and data processing and all those things. Okay. So for this, I'm going to import a library called as Pickle. So Pickle is the library which kind of helps us for this. And I'll put a text here as saving the trained model. Okay, yeah. So I'm importing this Pickle library and I'm going to create the file name. So file name is equal to, let's call this as trained model .sav. So I'm using the extension sav, which is like some saved file. You can also use the extension pkl, which means like pickle file. So like both are we can do any one of those things. So I'm going to say pickle. So pickle is nothing but the library that I imported .dump. So when I say this dump, all the parameters, all the things that is learned by the model will be stored in this. So I'm going to say model comma open file name and file name comma wb. So file. So what I'm doing here is using pickle, I'm dumping it. So I'm dumping the model, which means I'm storing all the parameters and the learnings of the model. So that is why I mentioned model. So this model is nothing but the model that we have created. So if you have used another variable called as classifier, in that case you will replace this model by classifier. So this is the name of the model that you are storing. And how we are storing is we are opening a file and open file name. So file name is nothing but the name of the file that we have created, which is train model.sav. So WB means we are going to write a file. So we are going to create a new file and we are going to write something. So what we are going to write is this model. So the saved model. If you mention R, that means we are just going to read something. We are not going to edit it. So this is like editing or writing it. B means we are writing this in the form of binary format. Okay. So this will save my model. So if you see this files, there is no files called as train underscore model.sav here, right? So I'll refresh this. There is no files like this. When I run this one, this model will be stored. Okay, so if you go here, so this model has been stored and this model size is very small, which is like 3.52 MB. So all the things that you have done, so you have like got the data using this API, you have done all this tough processing, all those things, and you have trained your model, right? So all this learning of this model, learning in the sense they are stored in the form of parameters of this logistic regression model. They have been stored in this file. So you don't need to train this model again in order to make this prediction. So you can use this trained model itself in order to make new predictions. Okay, so this is how you kind of save a model that you have trained with some data set. Now I'll show you how you can use this model for new predictions. Okay, so first, as we have written a file, right? Now we have to load this saved model. So this part is using the saved model for future predictions. So for this, first we have to load this model. So I'm making a comment here as loading the saved model. Okay, so loading the saved model. So I'll create a variable as loaded model. Loaded model is equal to pickle.load. So for saving the model, we have to use this pickle.dump. For loading this saved model, we have to use pickle.load. So in this, we have to say open trained model CSV, or if you have just have to copy the path of this model that we have created. So I'll copy the trained model SAV path, I'll paste it here, and here we have to read this file. So you shouldn't mention this as WB, you have to mention this as RB. RB means we are reading the file, whereas W means we are writing this file. So here we are not writing anything, we are reading the file, or we are just extracting this trained model, and again we are reading this in a binary format. So I'll run this one. So now the model that we have saved will be loaded to this variable called as loaded model, and now we can use this in order to make new predictions. So I'll say x new is equal to x test of let's say 200. So x test of 200 is nothing but, so we have this train test bit, right? So in this train test bit, we have this x test, which is my test data. So these are the data that the model hasn't seen before, right? And this test data has about like 3,20,000 data points or 320,000 data points, right? From this, I'm going to print the 200th data point, and the corresponding label has been stored in y test, right? Yeah. So let me print this y test as well. Y test of 200. Okay. So this is my 200th tweet in my test data, and the label is 1. So when I use my model for this X test, it should predict the same label as 1. Let's see whether it is doing it. Okay. I'm going to say prediction. So this is where I'm going to save my new prediction. So prediction is equal to model.predict x new. So x new is nothing but that one single data point for which we are going to do the prediction. So x new, I'm going to print the prediction. So it will print whether the value is either 0 or 1. So print prediction, and if this prediction, I'm creating an if else condition here to print whether it is a positive tweet or a negative tweet. I'm going to say if this prediction of 0 is equal to 0, in that case I have to say that I have to print it is a negative tweet. So we know that if the label is 0, it means negative tweet, right? So negative tweet. Okay, negative tweet. Else if the prediction is kind of, if the value is 1, in that case we have to print that it is a positive tweet. Okay, let's run this one. Okay, here the first one is the true label. So as you can see, y test of 200, this one which is in the square bracket is the value predicted by our model, which we have stored in this prediction. So this print prediction will give you the result like this. And if the value is 1, we have to say it is a positive tweet, because we know that if 0 it means negative tweet, if 1 it means positive tweet, right? So that's what we are doing here. The reason we are mentioning this square bracket here is the result of this prediction, the result of this model dot predict, or I can also use this loaded model. So instead of using the model that we have trained, so this is the saved model. So they are actually the same thing, because we are just loading the same model here. So the result of this model or this prediction will be stored in a list. So this is a list with one value. So when I say prediction of 0, that means it is the first value within this prediction. So when I say when the first value of this prediction is 0, I have to say negative tweet. If not, I have to say it is a positive tweet. So in this case, the value is not equal to 0, right? If it is 0, it would have shown it as negative tweet. If the value is 1, it is showing this as positive tweet. So I'll copy this one, I'll just paste it here, but now I'll use a different value. So I'm going to say a different index, which is 3. Let's see what is the index, and like whether it is a positive tweet or a negative tweet. So this is my true value, which is 0, which I have printed using this y test of 3, and I'm comparing it with the value predicted by my model. So my model have predicted the value is 0, so it has predicted correctly. And if the value is 0, we have to say it is a negative tweet. So here what we are doing here is like we are checking whether the model is predicting correctly. So you don't have to print this, but I'm printing this to check whether the model is predicting correctly. If the model has predicted 1 in this case, then it is a wrong prediction, because the true value is 0, but the model is predicting 1. Whereas in this case, it is predicting both the values as the same. So it means like the model is making correct predictions. So this is how you can use the saved model. So instead of doing all those processing, so once you complete this once, you don't have to do this again. So you can save this model, you can download this, and you can also run this in your Spider or PyCharm, and you can make this predictions like this. And this is how we kind of do this. So I hope you have understood all the things covered in this one. So I'll just give you a quick recap of all the things that we have done here, so that you understand what all the processes that happens here. The first thing is installing the Kaggle library. The purpose of this is to use the API in order to extract the data directly from this Kaggle site, right? So we have installed this Kaggle library. So we have seen that it is already pre-installed. So this is like a standard code that we have to use. So you don't have to change anything. So after like installing Kaggle library, we have to upload this kaggle.json, which we have got from this Kaggle account, which I have shown you, where we create this new API token and so on. After that, we have to configure the path. Later, we have to copy this API command, and API command is present in this option, copy API command, and it will copy this API. So this is my API command. It will load the data directly from the Kaggle to this Colab environment. Okay. So if the dataset file is small, like 10 MB or 20 MB, in that case we can download. If it is like large, like 1 GB or 2 GB or 10 GB, in that case it is always advisable in order to use this API instead of downloading it, so that it kind of happens quickly, and no expenses, like no data expenses will be from our end. So this will happens automatically through this API. So like this 20 MB or this 1 GB, whatever the size of this is not detected from your particular data package. Okay, so that is other advantage. And then we know that this is stored in the form of a zip file. So we are extracting the sentiment 140.zip, and after that we are importing the dependencies. So we have various libraries like numpy, pandas, regular expression, etc. So once we have imported all these things, we are downloading the stop words. So stop words are those things that doesn't have that much contextual importance to the tweets. After that, we are loading the data from the CSV file to a pandas data frame, and we have seen like there are totally 1.6 million tweets. But the problem is it is not reading the column names. So we are creating the column names, and then we are loading the data frame again, and then we are checking the shape, and then we are checking whether there are any missing values using the seasonal function, and then we are checking the distribution. Here we are converting all the 4 values to 1, so that it is very convenient for us. And then the important step is performing the stemming operation, which is to reduce a word to its root word. And later we have applying the stemming function, right? Okay. So after this stemming function has been done, the next step is creating a new column called a stemmed content. And later uh, this is taking a bit of time. Okay, so we are performing this train test fit function. As I've told you, this training data is used to train our machine learning model, and test data is used to evaluate our model. So that is the reason. And later we have to like do this vectorizer, where we convert this textual data into numerical data. Yeah, so it is present here. So TF-ID of vectorization. Later we will train our machine learning model after this. And once we train our machine learning model using this model.fit, we are using this accuracy score in order to calculate this accuracy. Later we can save this model using pickle. So yeah, so we are saving the model and loading this pickle model here. So this is like loading the pickle model. this one. So this is like saving the model, and this is where we are loading this model, and finally we are just using this train model in order to see whether the tweet is a positive tweet or a negative tweet. Okay, so I hope that you have understood all the content that we have covered here. So I suggest that you please practice all the codes that we have done here so that you can understand all these things better. So that's it from my side, and I'll see you in the next upload. Thanks for watching.